Can I have a wonderful applause for Winand Slingenbergh?
Thank you. Thank you for that introduction. Today I'm going to talk about 3D printing in general. Before I begin, I always like to ask, and it's different every time, who here owns a 3D printer? It's 1, 2, 3, 4, 4.5. OK. So as you can see, 3D printing, it's not so popular that everyone has it at home. It is popular enough that we read about it a lot in the media. And that's something that I want to talk about today, trying to separate the hype from reality. And I want to talk a lot about what the potential of 3D printing is and what still needs to change for it to have a very big influence. My name is Winand. I'm one of the lab managers at the Stichting Foundation Fab Lab of Groningen. It stands for Fabrication Laboratory. In Dutch, it sounds very bad. It's a Fab Lab. It makes it very memorable. I'm still not sure if I'm happy with the name. But I always start with my talks with this picture. Just out of curiosity, has anyone seen this picture before or seen this chair? See one hand. Yeah, there was an exhibit in the Groningen Museum by an artist called Joris Laarman. And he works a lot with digital fabrication equipment. And I'm going to talk about 3D printing today, but in general, I use it sort of as a proxy for digital fabrication in general, which means that you start with a 3D file, so a digital file, and then you make something physical, real out of that using production machines. Well, this designer, he likes to play around with the concept, see how the art of, how design is changing, and he invented this chair. Now, this chair is something you can download and print piece by piece on even the most accessible plastic printers. And then you can click it all together, and this way you can literally start downloading your furniture or the things that we, the tangible objects that we know, which previously were immune to, all of these sharing kind of things, which we know from music when the MP3 format came out, or when streaming became popular from TV shows and films. It's now also becoming a reality for tangible objects. So he created a company called Bits and Parts, and the whole idea is he publishes things under a Creative Commons license. You're free to download and use them yourself. There's a non-commercial clause in there, so you're not allowed to sell them, but this is indicative of something that's coming. All of these tangible things are becoming downloadable. Now, I want to share this slide. Does anyone recognize this out of curiosity? Yeah. I thought it would do well under this audience. In 2004, there was a public service announcement in the US, which was talking, trying to dissuade people from pirating different things, either films or music. And one of the things, one of the slogans, or the beginning slogan, was "You wouldn't steal a car." Slowly, it's become a joke on the internet. You wouldn't download a car. Well, I have news for everyone. Nowadays, it is possible. There's an open source car, OSV. It's an electric car. You can literally start to download it. There is a little thing that you need to do first, and that is share it with other people, which is a central theme of something I want to talk about today, and something which I think is very important in the world of 3D printing. Well, let me start a bit talking about the Fab Lab, or the Fabrication Laboratory. It was started at MIT around 12 years ago, and it's the brainchild of this professor. Now, this guy, he taught a course at MIT, which was accessible to anyone following any different course, essentially, and it was called How to Make Almost Anything. Or in other words, as I like to call it, How to Be MacGyver. But in teaching this course, he realized that turning on these machines isn't that hard. It's just a question of pressing play. The machine does all the work for you. So the real skill set that you need to learn is just to design something in a digital environment. And the older generation all learned Word, Excel, and email. It's really up to us to just learn a bit of basic 2D and 3D modeling, and then we can start using all of these machines. And there were all these spin-offs, all these great companies which followed out of MIT and became large, started making lots of money. It was a pride and joy, this fantastic thing that MIT did, came out of the center of bits and atoms. And this already says it, this whole department doesn't really make a distinction between the physical world and the digital world. It sees it as information, and it's easy to go from one way to the other, from a digital file to 3D printing it and making it reality, or 3D scanning something and making it accessible through virtual reality. So you can go both ways, and you can have lots of interaction between the two. But he realized it's not so hard for people to do this, so what he did is made kind of a list of ingredients, which is similar to the room that the students had access to. It was filled with a 3D printer, laser cutter, CNC mills, vinyl cutters, a whole bunch of computer with the right software to do the modeling. But most importantly was the culture that was created in these labs. So the machines are great, but essentially they're just computer-controlled things. A 3D printer people talk about it like it's really new and exciting, but really it's just a computer-controlled glue gun. And instead of a glue stick in the back, it's plastic filament. And if you melt that and lay it down carefully enough, you start to build up 3D objects. But it's really not that special. A laser cutter, you can cut through, let's say, pieces of wood. It's nothing more than a computer-controlled mirror. Yes, there's a very powerful laser shining on it, but really it's just a computer-controlled mirror. CNC mill, computer-controlled drill, essentially. It's really not that special. Vinyl cutter, computer-controlled knife. So the additional value comes in from being able to use all these machines and also to integrate all of these different techniques together. And after having come up with this list, there were a few people who thought this was a great idea, saw a huge potential in this, and started up their own fabrication laboratory in their own city. Well, in the meantime, we've grown into a network of about 1,000 labs worldwide. All of these labs have the same equipment, which is great, because if you're making digital files, you can very easily upload them to a server somewhere. Someone else can download them and start production locally. You can cooperate on projects, even product development, and these are classic working structures which we know from the software world, but in hardware this hasn't really been very possible yet, at least in product development. And this is slowly starting to come. Well, also in Groningen, we had one of these. This was one of the first in Europe, and the whole idea was that you would have this interconnectivity between labs, and there was a video uplink, so you could wave to your colleagues in Nairobi, and that was great fun. Unfortunately, the network grew too fast. Now we're 1,000 labs, so we're working together at more local levels. So Benelux is working together, France is working together, US is working together. But the idea still stands. As long as you share your files together, you can make fantastic things. Now, a little bit about my background. I don't have a background in computer science. I'm a physicist. I was working at the nanoscale. I was essentially doing 3D printing. Now, this is supposed to be a small house among some trees. It's 3D printed in glass or silicon oxide on a silicon wafer. And I'm not sure if these scales mean anything to you, but the whole thing is small enough to fit on a red blood cell. It was great fun working with these techniques. I did some 3D printing with an electron beam, but the sad reality is that these techniques are still very expensive. I was working on research for Intel, doing mask repair, which maybe would see the light of day in about 10 years. But what I really enjoyed was being able to press a button, see what breaks, learn from that, adapt, and change very quickly. So I kind of left that world behind and started looking at these machines, the computer-controlled glue guns. Now, this is a 3D printer made from your local hardware parts, a whole bunch of 3D printed components as well. So anything that you see that is white here is a 3D printed component. And this is what is called the RepRap project. So it's a design competition, and the whole idea was to make a printer which consists of 3D printed parts. Anything that's not a 3D printed part is called a vitamin. And the design competition is let's try and make a 3D printer with as few vitamins as possible. Now, slowly this project has grown, and a whole bunch of companies have been spun out from this. But the very interesting thing about this is that this was published under a Creative Commons license. And this is, in my view, the only reason that 3D printing is so ubiquitous now. So 3D printing, it might surprise you, has been around since the 80s. The technique isn't that special. You're just putting things down layer by layer and building up an object. What makes it very special is the price point. And what happened was the patents ran out after a while. That means the hobbyists started building printers out of old computer parts and things they could find, flatbed scanners and the like. And only then was it cheap enough that people started buying it. As soon as people started buying it, the material scientists started developing new materials for it. And only now are we in that sweet spot that the designers are actually using this 3D printer to design a whole new class of objects for it. But this was published on a Creative Commons license, which means that any derivative work from this, so say I were to build this printer, I would come up with a new or better way of doing this, I am obligated to publish my innovation under the same license as this was published under as well. So it has this viral license. And the great thing of this is that this really spun out a whole bunch of different companies. I'll refer to these companies a bit later on. But first, I'd like to talk a bit more about 3D printing. So 3D printing is really a production technique. And what we're really talking about is additive manufacturing. Put it very simply, you start with nothing, you keep adding material until you're left over with something that you want to have. And the way of doing this, I mean, there are several ways of doing this. Is there a laser pointer here? Yep. So the one that we know the best, I think, is FDM. It's your plastic squirting 3D printers, which are affordable from a few hundred to a few €1,000. The other techniques, your metal printing and your full-color sandstone printing, binder jetting, these are all way, way more expensive techniques. The machines, start from, depending on the technique, but say 50,000 onwards, especially these metal printers that can print entire motor blocks. These are so expensive that they only have very small use cases as of now, just because of the price. So what really interests me is these really low-cost printers, these FDM printers, because once technology becomes ubiquitous, people start using it, and that's the only reason, that's the only time you really see the innovations. Now, when talking about 3D printing, very often people are putting it in a context of, Industry 4.0. Just out of curiosity, does this mean anything to anyone, Industry 4.0? Great, because it doesn't really mean stuff to me either. It's, it's put in context of industrial revolutions, and basically it means the integration of cyber-physical systems. So you kind of have data, big data collected from anywhere, integrate that into your production technique, and have decentralized production hubs. But very often when talking about 3D printing, I'm asked to talk about all these fantastic new things that you see, 3D printing of food, houses, all of this stuff. And they want me to use all of these buzzwords as well, but it really feels like I'm playing some buzzword bingo most of the time. And I found this image online, and I kind of find this is funny. I mean, we're at DisruptIT. It's the central square here. I'm talking about 3D printing. We've had the Internet of Things. I'm sure Moore's Law has been named a few times. But what I really like to do is to just look at this in a very sober way and to evaluate, well, so what's reality in 3D printing? What's actually possible? And what are the really big positives which we really need to focus on? Well, let me start with the negatives. It takes a really, really, really long time. So for the people who have a 3D printer, you might be nodding yes furiously now. Just to print a very simple object, say a vase, it can take up to like 12 hours to print something like this. So say you want to produce 500 of something, well, either you need 500 printers to produce it all within a day, or you need to be very, very patient. Generally, for production, this is not a very suitable technique. And since you're 3D printing, every axis in which you scale the object increases the print time. Make something twice as large, it takes 3 times as long to print. If something takes 3 times longer to print, there's 3 times higher risk of it failing. And 3D printers fail quite a lot. So I work with the accessible models. I've spent quite a bit on a printer, which is supposedly one of the most user-friendly printers in the world. I still only have a success rating of about 80%. Now, this is a 3D printer that tried to print a structure about 1/5 of the way through. It started running into an error. Well, these machines, they're not very smart, or they don't have many feedback control mechanisms. They don't stop automatically. They just execute their code, follow that pattern automatically, and they will squirt plastic no matter what. So I've printed quite a few spaghetti monsters, as I call them. But this is the sad reality of 3D printing. It's not reliable enough yet for us to use quite a lot. And so these two factors combined, the fact that it takes a very long time and it's not reliable enough, means that it only has very selective use cases. But the use cases that we hear a lot about are essentially these. So let me just start with the one at the bottom left here. SpaceX, Elon Musk's company that's supposed to take us to Mars, they 3D print their rocket engines. Now, the interesting thing here is that they use one of these really expensive 3D printers, but they're also one of the only companies that can actually use this at the moment, or use it and have it be economically viable. That's because the rocket engines that they have, they're modeled so carefully that there's actually no 5-axis CNC mill or something that can make those exact corners and to mill that block in one go. So they actually have to 3D print it to be able to get all of the energy efficiency out of this rocket. So this is a very limited use case because there's literally no other way of doing it. If there would be another way, that other way would likely be the cheaper way, just because these machines are too expensive. The medical sector is also something that's touted quite a lot. Now, there are two things that are happening in the medical sector. One is prosthetics. And the other one is to grow kind of scaffolding material over which other material can grow again. So say you're a burn victim, you're missing one ear, you can 3D scan your left ear, horizontally flip it, so you have the model of a right ear, print the inside structure as a kind of matrix, and that can be a medium over which other cell structures can grow. So you can then create a new skin, which you then can graft onto your other side of your head. So for cosmetic surgery, this is a very useful technique. Prosthetics is another one, and there's a great project called the Enable project, which using these really cheap printers allows you to make 3D printed kind of prosthetics. This, again, is a project where people over the whole world are working together. They upload their latest files to GitHub, share it in an open source fashion. It's fantastic to see. But again, yeah, the reality isn't quite there yet. And a big problem here is legislation. One 3D printer is not the same as the other. And when you're 3D printing, you need to be able to guarantee that every product is exactly the same, to be able to have some sort of legislation built around it. Or at least you want to be able to say, this is safe to use, but if your printer somehow fails, even if it is for just 3 seconds and doesn't put down enough plastic, this could mean that you have a cavity where bacteria can grow and your implant wouldn't work. So there's still a lot of work to be done there, and we're certainly very far away from the reality of 3D printing a heart or 3D printing a liver. I'm also very skeptical that that will ever be the case, because more likely you'll kind of create a microfluidic chip which has the same type of function as a liver and implant that rather than to actually create something cell by cell from the basic building blocks of life. Another thing that's mentioned a lot is 3D printing of houses, and I'm sure you've seen some YouTube videos about this, and there's quite a lot of hype around this. And it's pretty cool to see what is possible. You can theoretically print houses in any shape based on models of where the sun goes. You can position those houses and have them automatically be generated to catch as much sunlight, so you can put solar panels there, collect water at just the right points so you can flush the toilet at the floor so you don't need to pump water up. So you can gain all of these wins in terms of efficiency. The problem is that you always need a printer that's bigger than the house that you're printing. It's really hard to have a smaller printer than that, which means that if you're printing on location, either you need the space around it, which can be hard if you're printing in small areas. Typically, the only place where you see this is new development. But in new development, generally, you're printing many variants of the same house. In that case, it's much, much easier to build everything prefab, ship to location, and put it together that way. It tends to be cheaper and easier. And the sad reality is most of the 3D printed houses you see, they're printed in a shed somewhere. They have to be printed indoors because it needs to be a controlled environment, and then shipped to location anyway. So it's just a different way of prefab. It's not printing on location out of local resources either, which is a bit disappointing. Now, there's a great project in Amsterdam, the SNiC-NL house. They're trying to 3D print a house there, and they're really seeing it as a 10-year research project, doing all of the research and doing it properly. Whereas in the meantime, there are some companies who built their own, cement 3D printer. Typically, there are quite a few Chinese companies that have done this, and they quickly 3D print a house, which is great, but they 3D print square houses. So you finally have this machine that can print pretty much any shape that you want. It's sort of disappointing to see that they go for the square shapes once again, which technically is easier to do with prefab. Now, one last one, this is a bit of a pet peeve of mine, is 3D printing food. Now, I enjoy food quite a lot. I enjoy cooking quite a lot. But you hear all these stories about 3D printing food. So there's, just for the record, there are 2 types of 3D food printers already on the market. One is a chocolate printer, and one is a full-colored sugar printer. Now, the full-colored sugar printer has some applications when you're doing cake design to make very nice ornamental shapes for wedding cakes and the like. The chocolate printer is a disaster in my eyes. Making chocolate is actually an art form to make it taste good, and you need a very specific temperature to get it just right. But to have ease of 3D printing, unfortunately, you need to throw up the temperature quite a lot, and you get all this crystallized kind of chocolate out of there. So your end product, it may look nice, but if it doesn't taste good, then why are you 3D printing food in the first place, would be my question. T&O has done some very interesting research, which is what this picture is. So they got a dough printer, and they 3D printed this kind of lattice structure. And on the inside, they put a gel with spores of mushrooms and different herbs in there. So the idea is you have a 3D printer print this, then wait a few days until all of this grows. Then you can put this in the oven, and then you can eat it. Well, I don't know how long you guys take to cook something, but I think it doesn't take a few days to prepare it. And this will always be a limitation when you try to do things this way. So yes, there are some benefits to producing food. Yes, you can do some interesting things, but I doubt that we'll be 3D printing our burgers in the long run. OK, so what is it useful for then? Well, there are essentially 3 use cases which I've identified. One is rapid prototyping, and this is what 3D printing is mentioned, is always very good for, and that's the speed. So in your classic way of designing something, you want something plastic made. You make your 3D model, you send it to China, and for 10,000 euro, they can make several hundred or several thousand parts. And until you see the plastic part, you can't make your second iteration. Often to only discover that you put the screw hole in the slightly wrong place, or your hole is slightly too big, and you can't really readjust that because you paid for an injection mold, which costs in excess of 10,000 euro. And then you have to start all over again. With a 3D printer, you can quickly try something, and as long as your digital, as long as your file is digital, you can quickly make some adjustments and then print it out again, see if that works. So for rapid prototyping, it's a fantastic tool, and it's actually faster for single objects than doing it in the classic way, though 3D printing, admittedly, is not very fast. Another thing is spare parts. Right now, when you order spare parts, say your microwave is broken and the button is broken, a small piece of plastic, to get it replaced costs almost as much as a new microwave. The reason for this is that you're not really paying for the piece of plastic. You're paying for storage and shipping. You're paying for logistics. So companies have a great incentive to essentially allow 3D printing companies to print out spare parts on demand, so they're not stuck with storage, they're not stuck with the logistics. This does bring up one thing, which is that they have to share the files with the world at large. Obviously, when you're a capitalist company trying to make money, it's not very wise to always share all your design files with the rest of the world. So there's a small risk there. Another thing is small-scale production, and this is what is meant by Industry 4.0. Essentially, right now, when you make a car, you have to set up a production line, tool your entire production line for one car. This is also why you see that cars, generally, they share the same chassis, or the bottom part of the car. That's because if you were to build a new line of cars, you'd have to retool the entire factory, which is very costly. So if you instead can switch to kind of universal production machines, which don't need retooling, but have all the tools already built in, you can have tremendous cost savings, and you don't need to have economies of scale, so produce 10,000 cars before you get the returns, essentially, of spreading the cost over these multiple objects. So small-scale production runs is possible. So in the future, it's very possible that you can start producing engine blocks with metal 3D printers in sets of maybe 50 to 100, at which stage you already have some feedback from the consumer. You can adjust the car and then print out new motor blocks. You much more have a kind of a running development while producing things, and that's one of the new use cases for 3D printing. The problem, well, with most of these, especially with share parts, is that you have to share things. And the sharing thing is something funny in the 3D printing world. I already mentioned it with the chair in the beginning. Objects are now becoming downloadable, easy to exchange. And 3D printers as well, with the RepRap project, are exactly the same. Now, there's this guy, Joseph Prusa. He was building 3D printers just for fun and trying to make the RepRap printers and trying to make them more accessible so that you could build them in a weekend with as few parts as possible. Now, he was sharing all of his files online for free. He was producing his parts with a 3D printer. So all of the use cases that he had, he was prototyping with them, he was making the spare parts for them, and he was doing small-scale production runs, all with the 3D printers. So this guy really knows what 3D printers are all about. And he was sharing these files open source with the rest of the world. Now, just by making a better printer than anyone else, people started buying directly from him. And right now, he's grown into Prusa Research has grown into a company which is 40 researchers strong. And this just started out with a hobbyist who was kind of, building 3D printers for fun. Every new printer that comes on the market by him is also touted as the best new printer. And he still sticks true to his ideals. All of these printers are open source. In theory, you could just download these files, print out your own version of this printer, and be on your way. The sad reality is, though, as soon as you've printed this out, he's probably come out with a new model which is even better and necessitates you to update your 3D printer as well. Now, this is an interesting case study. I don't know who's heard of Ultimaker before? Yeah, quite a few people. It's quite a famous 3D printing company. It was, again, some guys just for fun building 3D printers, the RepRap printers, sometimes in a Fab Lab in Utrecht, sometimes at in their kitchen. But at a certain point, they had this insight: we can use a laser cut case to improve the quality of these 3D printers. Well, simultaneously in the US, there was a company called MakerBot who had a similar type of insight. But then, because they based their entire design on open source models, they were faced with this choice. If we want to sell these printers, are we going to pretend that these design files are our own and just sell it as our own files, or are we going to uphold ourselves to these ideals and share these design files with the wide world under the same Creative Commons license? Well, Ultimaker, a Dutch company, decided to uphold these ideals and share it with the rest of the world. Of course, they faced the risk that China would just download these models, produce it en masse, and they'd sort of price themselves out of the market. MakerBot pretended everything was theirs. Fair enough. That way they could get some investors in the US. That's, it's very important to be able to show that you've protected your intellectual property. But what happened? All of the hobbyists started to buy this Ultimaker 3D printer. Why? Because they had the design files. They owned the object. If something would break, they would have the file to be able to print out again and fix their own 3D printer with it. But the real added value was that all the hobbyists that built or bought the Ultimaker, they were usually very technical people who came up with own innovations of their own, and they were required by the Creative Commons license to share this with the rest of the world as well. So effectively, Ultimaker outsourced their research and development to hobbyists worldwide, where MakerBot had to pay very expensive engineers to solve all of their problems. Well, MakerBot is losing market share like no tomorrow. Ultimaker is taking over the entire American industry as well, American market as well. And this is one of the big success stories about how you can run an open source business model and still be successful. The key is always that sharing can create additional value. Now, Ultimaker is also one of the only companies that has actually gotten multi-material printing to work for a price point below €5,000 reliably. So again, I say reliably about a 80% chance of success, I call reliable. But this is really the future of 3D printing, multi-material. If you imagine that you have flexible materials and non-flexible materials, you can make very ergonomic type of designs. If you have conductive and non-conductive, you can embed your electronics in there. If you start to combine multi-material with pick and place, well, then you're really starting to talk about universal production machines. But in the road to get there, right now, this is really the only option. I've spent about €1,500 trying to build my own multi-material printer. I'm now 2 years down the line. I still haven't gotten it to work. So props to Ultimaker to actually being able to do this, and they did so with an open source business model. So yeah, this thing about sharing, I think, is a very important thing in the 3D printing world. Most 3D printers are cheap because people have shared the ideas with each other. But the future of 3D printing all depends on to what extent we're actually willing to share things with each other. Now, there are a couple of companies who are who see this kind of the shifting winds and are playing to it. So there's a company called McMaster-Carr in the US. They produce all sorts of components that are in all sorts of machines. The great thing they have is you can literally download 3D models of everything that they make. obviously, there is a significant risk to sharing models that you make as well, because China can reproduce them quite easily. But what they notice is that they can actually create a competitive advantage by sharing things. Why? If you're designing something and you need to put components in your 3D model, what are you going to use? The company that you can just download it from the website, or the one where you have to model the component yourself before you can place it in your 3D design? Well, probably this one here. So McMaster-Carr is actually getting more market share by sharing all of their models online. So this is the first indication that there's added benefit from sharing your models, but there are a few extra steps. So IKEA is your classic example of mass production, essentially. You have everything standardized, and you produce it as cheaply as possible, and it's only possible to produce it that cheaply is because you produce so many of it. Well, now you have that world meeting the world of kind of customization of 3D printing, and you have all these kind of IKEA hack websites where you start out with something that's mass-produced, so you get the benefit of the cost benefit from that, and then you can personalize it in the last step. So you can either combine IKEA furniture. I actually haven't. I brought some stuff with me. I almost forgot. So here I have an IKEA lamp fitting. Whoops. An IKEA lamp fitting, so this cost, I think, $129, if I'm not mistaken. And then I designed something in a 3D environment, 3D printed that myself, so I created my own lamp, essentially. And this is a new paradigm, essentially, kind of mass customization. You can get the best from both worlds. And initially, it will just be the combining of mass-produced things with the custom things. But we're also going towards a world where designs are parametric or are generated. This is called generative design. Well, this is another chair by Joris Laarman, the same designer who I introduced in the beginning. Okay, a chair is a classic design object because it has a utility and it has a look, so you can experiment with how to do this. But he worked together with a researcher who modeled bone growth. And bones, they have a very strong structure and also are very lightweight. So you have essentially an optimization happening there, as strong as possible with as little material as possible. So what he did with his chair, he defined essentially this as the seating area, this as the back area, and then had this algorithm essentially solve what kind of structure it should have to be able to be as lightweight as possible, yet be as strong as possible. So he calls this the bone chair. It was 3D printed. But this is, again, one of these examples of a new class of products which is coming, generated products. And slowly but surely, you're seeing this in the consumer markets as well. So based on, say, the 3D scan of your foot, you can have a fully generated 3D printable shoe that can come out of it. Say you are a company and you want to have your logo on everything, because apparently companies want to do that. You can have it so that your logo is at the bottom of the sole of your shoe. So wherever you walk, you leave your logo behind as well. Well, all of these, it might not be the most interesting examples, but it shows something that's changing. And the interesting thing is you can approach this in two ways. Either you can have a website, have it upload your a 3D scan of your foot, and they will print it for you and then send you the shoe. Or you can do it in a more sort of open source fashion. So you make this algorithm and share it freely. The added benefit is that in the second model, you kind of create a brand name. You are the authority on this type of model. And using that brand name, you can get a larger market share and use that revenue to keep innovating with the product. And by continuously innovating, you can keep your competitive advantage. So it's the speed of innovation which really has this added value with 3D printing. I'd like to just end with this quote I found on the website of this event. If I asked people what they had wanted, they would have said faster horses. The reason I bring this up is when I talk about 3D printing, people always have certain expectations, especially when we're talking about plastic things. They expect it to be as cheap as the stuff that's mass-produced in China, and they expect it to have the same surface finish, while not really identifying the correct use case for 3D printers. So again, I'm no Henry Ford. I'm just a huge 3D printing nerd. Hopefully, I can share a bit of my insights today. Yeah, I think right now the problem is people are expecting things to be the same things to be produced just with 3D printers rather than 3D printers creating this whole new market segment of new class of products, which can be essentially derived from a set of parameters, be it data, 3D scans, it doesn't really matter. So I'd like to end there. Thank you very much. And I'd like to open it up to questions. I hope there are quite a few. Thank you very much.